there is a difference.
Some things change in the firearms world slowly. So for some strange reason, somebody thought a 44 caliber projectile with 20 grains of black powder underneath it was big, dumb, and slow, and I would say that it was slow. Anyway, two Italian Bodeo revolvers. One is not Bruno's, one is Bruno's, and guess what? Bruno got a deal. So let's go and look at screws that are Phillips heads that are on this that need to be replaced. We'll talk about how the side plate is held on, and we'll also talk about a built-in spring cramp, little gizzy right here that got a little bent, and see if we can bring this Bodeo back to some semblance of operational capacity. And by the time we get done with it, we'll have a before and after conservation look that should give even some collectors a little bit of pause, because it's time to do the maintenance. Let's go. One of the first things that's wrong with this revolver is that Phillips head screw, right? Yeah, there it is, right there. Yeah. No, we got to get rid of that, and God only knows what the thread pitch on that is. I get a lot of grief because I work in Imperial units a lot, because the guns that I work on are Imperial. This gun was probably Italian metric, and I say that as a joke because there's English metric, Italian metric, Finnish metric, French metric. Pick your metric. But in the meantime, there's a couple things we need to know. This particular screw, and I'm going to draw this here, and I know this drives people nuts, but this particular screw has got a head on it, and then it's got a body on it like this, and then in a smaller size it has a set of threads on it. Okay? That's what this screw looks like. I've just blown it up so you can see it. This is a pivot shaft. It's a bearing. It's a plain bearing. And then we have a set of threads here that hold it in, and they've made a step here, and this step means the screw will torque down against this shoulder without pinching what's in between it. All right. So what was I talking about on metric threads? There's two different ways to measure a thread pitch. Okay? In the English system, they are looking at the number of crests per unit distance. So this is, if this is, we're going to say that's 1 inch, because that's typically what they're talked about. So if they talk about a 1/4 20, they're talking about a bolt that's 1/4 of an inch in diameter and it has 20 thread crests per inch. On the metric side of this, what they're looking at is the diameter of the thread and the distance in between in millimeters. So this is in millimeters and this is in millimeters. So an M4.7 by 10 is a 4 millimeter diameter screw. The distance between the crests is 0.7 of a millimeter, and then it happens to be 10 millimeters, 20, 30, 40, 50 millimeters long. So part of what we're going to have to do now, we're going to fold over, we're going to redraw this screw, and we're going to find out exactly what we got. What we're going to find out is there may be an English equivalent that is so close that you won't know the difference. And the gunsmith equivalent of that is, I don't know what it was, but I'm going to tell you what it's going to be. Let's see if we can get around that. The screw that we're trying to replicate is in the middle. The 3 on the bottom is a 2 millimeter, a 3 millimeter, and a 4 millimeter. And the longer screw on the top is a 440. And I got to tell you, the 440 is actually the closest, and it's within the error. Now, even though the threads on that long screw are 440, we don't have the shoulder. This is the screw that's going to have to be made. So having said all that, the 440 screw does thread in here, and I'm going to tell you what, it threads in without a whole lot of slop. And as I just said, the body, however, is not larger in diameter. The body of this has to be a couple of thousandths larger than 200. Now again, why am I working in English units? I'm telling you, all these English units on this thing are coming out perfect. 130 thou right there. So this 30 in diameter there, but the threads on a 440 are 0.086. So we have 86 thousandths of an inch here and 130 here, and it looks like a big jump, but it's not. But what it means is we're going to get a piece of 1/4 inch stock, and let's talk about how the heck we're going to make this screw. So again, after a little dissolve here, I got us a clean mat. Let's look at this really quick. We're going to take a 1/4 inch rod, 250 thou, right? And then we're going to take that 1/4 inch rod and we're going to turn it down to 200, and that's our head diameter. And then we're going to take the head diameter, turn it down to, what was that number I said it was going to be? 130. So we're going to start out at a 1/4. So this is 250. And then we're going to come down here to 200. And then we're going to come down here to 130. And then we're going to come down here again to 0.107, which is the major on a number 4. I know I said 086 later, don't worry about it. We're going to make these cuts, and in between these steps, this is going to be how thick the head's going to be. This is how thick the bearing's going to be. And then this is how thick right here the threads are. Boom. 3 turns. We'll go do all that on a lathe, and then when we're done, we'll come back in here with a 440 die, because I'm blind and I am not turning 440 threads on a lathe. Have a nice day. I'm sure the professional machinists are having a freaking conniption right now, and I don't really care. The size we're turning right now is the diameter that we want the head of the screw to be. And we'll even leave it a little bit big. I know I said 200, but we'll leave it a little bit big. And we're just, see, it's about 1/3 of the way down, so we don't have too much further to go. It wasn't going to take much. Come in another couple of thou. Now, yes, this is a lot longer than a screw has to be, but I'm going to leave the head sticking out one side and the thread sticking out the other, and then we can just cut them both down at our leisure. Yeah, cut and try, cut and try, cut and try, but once again, we're making parts for an old gun. And by the time I set all this up to measure it the right way, it's quicker to just do it this way. We're just about there. I'm going to leave it a little bit big, because then I can trim the head to fit completely into the mortise. Alright, we're just about there. So then we're going to go to our second number. So now we set to 130. That's within 5/10 thousandths, and I doubt this thing is that accurate. We only need a little bit of head. The head on this thing is only going to be back to here, so we're going to cut this 130 back to damn near back end of it. There we go. So we're just going to say that this plunge right here is the 130 point. We'll come up and we'll cut a nice deep shoulder right up there. Again, I know the professional machinists are going nuts. I've been kibitzed by professional machinists for years because I suck, but hey, whatever. The difference is by the time you get done laying it out, I've already got my gun part and I'm moving on to it. So you can see there's a step starting to show up there. And we'll come up here, pop out, and just take a quick look to make sure we see where we're at. And we're not there yet. So where I've got the cross slide set isn't there yet. And I can actually come in and take a little bigger bite and cut going that way instead of cut coming this way. Is what I'm looking at. There we go. So now we've set to 130 thousandths, so we're going to push all the way up to the shoulder. So this is the diameter of the bearing. And I'm going to go get the trigger and make sure that it fits over that. Again, this is going to look a little goofy, but we got to see if it'll go through that. And it does. Just goes through that. So if we just kiss that with a file, that's going to be fine. Remember, gunsmithing is about 1,000th. We're not in the pressure boundary. We're not talking about containing high power center fire rifle cartridges. We're just talking about making a screw that articulates a trigger. This is not a fire control safety component. And there it is. There's our diameter right there. Okay. So now to see how far in it goes, we'll Sharpie this whole thing down. With the Sharpie, we set to 143, and that's how long we want the bearing piece to be. And we'll just come up in here. Let me get the headstock out of the way. And we'll just come up in here and we'll just touch this. So all we got to do is leave that silver line right there. That tells us how big the bearing piece was that the trigger articulates on. And now we've got to come into the next number, which is 107 thousandths of an inch. We'll come in and make a cut. Now it's not much of a shoulder, so we'll make a cut and we'll just remove enough that you can see where we're at right there. This is the part that we're going to thread. Now the threads are too long, and we know that. Okay, we're going to finish this up at a slightly different camera angle, so hang on for a second. I did move the tool and I changed my angles a little bit because I didn't like how that was cutting before. That's damn near there. And you go, why does he cut and try? Well, the cuts and tries because I suck at machining. I'm average at woodwork, but I managed to somehow succeed in producing parts for guns that haven't been made in 100 and something years, so we're doing something right. Okay, so this, yep, we're there. I like to leave them a little bit fat, especially when they're this small, because I like to have a lot of extra thread, and then we can just knock the tops off the crests with a file and then be able to trim it in that way. And there. Plus this lathe and my eyes are not that accurate. So I'm not going to be able to, this lathe will turn about 1,000th and about 1,000th. So for you metric guys, that's about 1/10, I guess. Bang, we're in the game. Now we can tap it. So here's what we've got. A 250 thousandths back body, a 200 thou bolt head. This is the bearing piece at 130, and this is where the 440 threads are going to go right there. So we're just going to take a die, run some 440 threads on this, and then we can start doing the fit up. I borrowed this cute little threading gizzy off of my automotive. He makes parts next door for old cars and stuff. He fabricates stuff too. It's the same game done differently. So what I'm doing is I'm watching to see if the die plate is spinning like that, and I'm correcting it because I would like it to go on perpendicular to the long axis. I think that's the right word. And then we're just turning it until it'll come down and stop, and it's actually threading it pretty good. So what we'll do then is we'll back off and then we'll flip it over and we'll cut with the back side of it. Okay, we'll take a look here. Let me get that curl up. So I'm threaded down almost to the quick. So I'm going to go in a little bit more, but I'm going to turn it around and thread it the wrong way because the die's got an open end and a closed end, and I would like these threads to come right up to the end here. I know my hands are in the way. I don't have a choice. All right, here we go. So this will come down, and I can feel it starting to bite, come up a little bit, and we got to come all the way off because we can't see what we're doing. Yep, a little bit more. A little bit more. Come up in there, tighten that, and come back. Okay. And bang, we got threads all the way up to the quick. This section of threads is too long. I know that. This bolt is 6 inches long. I know that. Now, once you take this thing out of the headstock, you are committed because you'll never get the screw to go back in the right way. And you can see where you mark these jaws. There's all kinds of little tricks and games you can play, none of which are ever any good. So what I will do now is I'm going to bring that frame up here or bring the trigger up here and just check the fit of these threads. So we know we got to go through there and we got to go in there. They're a little bit tight. We may want to set that die down just a bit more. Yep, there we go. So this is our screw so far. Screw head penetrates in. Bang, we got the bearing in the middle, and I don't know if that's showing up on this camera angle. Head, bearing, threads, we'll just file those off. And now all we got to do now is make the rest of the screw. Let's get back over to the vise. So the screw on the left is the one that we had. The screw in the middle is the one that we've made, but we haven't cut the top off it yet. The screw on the right had the right threads, but the problem was it didn't have a bearing surface, so the trigger was all kinds of loose. Because there was no bearing surface, the trigger was actually riding on the threads, and it was too small in diameter. Remember, we had about a 30 thousandths diameter increase for that step. We cut the screw head off of this blank. We just cut it off, and you take it over in the vise, and you just hack a slot in it, you see. And then, you know, we just showed you the comparison of what we got here. So remember now, this is a handmade screw, and you're taking up for a lot of, you know, years of wear. I've got to come that way. The high speed here. There we go. Handmade screw. Now this will get fire blued after we know it works. You guys have seen me do all this before. The big one was to know how to get all the steps in it. Let me get this reinstalled and we'll see what it looks like. That's uninteresting without live ammo. The Bodeo had the Abity loading system, and when you have the loading gate open, you can exercise the cylinder without striking the hammer, which allows you to load 10.35 Italian service revolver one round at a time by just pulling the trigger. So let's see here. We can load one in there and in here. Now, one of the things we haven't talked about is there is a annulus between the firing pin tip and the hole that it goes through. And if that annulus has been allowed to get large enough, and I'm only going to put 5 in this, There we go. There's 5 rounds in this thing now, and ordinarily it would be stowed with the trigger up so that the average Italian service guy, I guess they were, I wouldn't say they're not stupid, they were just uneducated so that they wouldn't hurt themselves. The officers had the model with the grips firmly down. So in a black powder setup, this is not a particularly powerful gun. It's black powder, it's not, as opposed to, say, a 44 Magnum, which will let you know that it's hair. You can see the difference in only 30 years. All right? So, 30 years you go from this. There is a difference, and it does matter, and this is a way bigger, way badder way to get things done. However, I still wouldn't want to get hit with anything. Now that we've got this thing dirty, we'll go inside and conserve it and get all the black powder out of it and call it a day. And it's time for a cigar, and we'll head back in the shop. Outstanding. This spring is the ramrod retention spring, and it was kind of messed up, so I had to get it and drill its hole out, whatever. But the thing I want to show you about these little itty-bitty springs is I'm going to show you down inside of this. If you can see that 45 ACP cartridge standing straight up, what that's doing is just holding the spring up above. Now oil, believe it or not, oil will not burn just because you put fire on it. Oil has to be brought up to a point where it's actually beyond its vapor temperature. So we'll warm this oil up. This is an alternative way you can temper a spring. A lot of the black powder books call it out. Mr. Ravenshire called it out. We're going to get this oil to boil in here. And once we get it to boil, it'll think about burning by itself. We're not quite there. There we go. We're just about there now. Here we go. Now it's burning by itself. Almost. Don't want the fire to hit the part. There we go. Now it's putting off enough oil to keep itself warm, vaporize, and get my part hot. Now it'll bring my part up to 500 or 600 degrees inside there. Guys have been tempering springs like this for years. And in case you're wondering, I have a roll door on my shop, and it is ventilated to the outside. It's a particularly nice day here in South Carolina. And yes, I do have a pot of oil burning. Behind me are a couple of fire extinguishers. It's not the first time I've ever done this. Don't do this in your kitchen. Do this outside on the driveway. Anyway, how to draw temper the old school way. So I've chased in the checkering here on these diamonds, and I've taken a file and sort of sanded off the nasty stuff, but this is an undone grip panel. This is a done grip panel, and in a second here I'm going to show you how to hang on to something like this. That's easy, you just run a screw through it. How do you hold on to that? I'm thinking that I drill a hole there, there, and there, and I'm thinking we're going to put in 2 screws and 1 down in the corner here. So we'll just take a drill bit screw, and we'll run it in here. A little bit more. Here we go. That's in tight like that. We're going to take this one, run around the other side. And we'll hang onto it there. And then I've put a brass washer on the top of this one just because I want to be able to play with a little bit about where it torques up. Okay, so now this thing is held in good and tight, and we're able to work on it. So the tool that I'm going to use for this particular exercise is a 75-degree bit, because I don't want to make these diamonds stand up at all. I merely want to delineate the grooves that come down in between them. So all I'm doing is recutting the grooves here, and I'll backlight this so you can see what I'm doing here. There's a groove there, and all we're doing is cleaning this out. I'm trying to be very careful to actually see what I'm doing and not get in front of the camera. That's all we're doing, is cleaning the schmutz out of those grooves. We don't want to get up on top. We don't want to do anything. Now, if you do screw up, and like here, I couldn't even see what I was doing, we still have a little bit of material here we can just remove down through the top, and you'll never even know we did it. Look at that. That went away. There. There. Yeah, I'm freehanding it. Now in this case, I'm going to have to reset this and jig it up in the air. I didn't even bother setting it up on my cradle. I got a crosslet here, and we can see that all we're doing is cutting that off like that, and then the tool's kind of skipping back on me a little bit. Be careful about that. There we go. So now I've cut the lines. Now I'm going to come back through and maybe cut the tops off this a little bit. That groove's a little bit maybe deep. And we'll do the whole thing. When you get done doing the whole thing, you put a little bit of oil on it, it looks like that. And the most important thing is that it doesn't look like we were ever here. Beginning gunsmiths, remember the trick is to get in and get out and not let anybody know you were ever there. All right. Here we go. This is the end of a tale of two Bodeos. One that has been done, one that hasn't been done. We did a lot of work on this revolver. When this thing came in, this side plate tensioning screw, there's a little screw that captures it to keep it from coming out. That was all messed up. We got that fixed. On this one, the spring that holds in the ejector rod was just torched. So we took care of that. We made a screw for the trigger retraction gizmo. I call this articulation, whatever you want to call it. There were some other things we did on the inside. We did the grips. We did a complete and total workover on the grips, and we delineated that checkering there and made that look good without it making it look like we'd roughed it up. These old ones here, you get the hand oils down inside in the checkering grooves, and it's not the same. So we got in, we did our thing, we came out, we did the full conservation. This is the finish that was on it. This gun would probably have to be rusted and pushed one more notch. And we actually shot the thing, and it's an example of the fact that you can run this older gear, but man, you got to do your homework. And just remember, when this kind of stuff pops out of a guy's collection, try to not mess it up too bad. Watch some of the videos, convert, do the maintenance. And as always, it's been a pleasure.